In this tutorial, we are going to look at tangents and secants that intersect outside of the circle. So you can see here that we have two secants. Secant, it's a ray in this case, AC. That's a secant because it intersects the circle in 2 points, and so is ray AE, which intersects the circle in 2 points. The key here is that these two secants intersect at this point, which is outside of the circle. And then we can see the same thing here. We have a tangent and a secant that intersect outside of the circle. And then over here, two tangents that intersect outside of the circle. So in this case, we can see that these two secants intercept two different arcs of the circle. So the first arc that it intercepts is arc BD. If I'm talking about this particular angle, in this case, I could say angle BAD, but it extends and it intersects this arc BD, but it also intersects this arc out here, arc CE, which is bigger. So the measure of this angle, angle A on the outside here, is equivalent to half of the difference of these two arc measures. So you always want to do the big arc measure minus the small. So in this case, it's the measure of arc CE minus the measure of the smaller arc, in this case BD, and you take that and you divide by 2. Now another way to write the same thing, you could say it is 1/2 times the measure of arc CE minus the measure of arc BD. But again, I like how this sets up a nice proportion for us when we're doing our work later. Each of these is very similar. So again, we're looking at the measure of angle A. I can see that angle A intercepts this arc here, arc BD. This is the larger arc that it intercepts. And then it also intercepts this arc, the smaller one, BC. So again, the measure of angle A is going to be the measure of the larger arc, in this case, arc BD, minus the measure of the smaller arc, BC, divided by 2. Again, when we have two tangents, it's going to be the same thing. So this angle A intercepts the smaller arc, BC, as well as the larger arc, BDC, out here. So the measure of angle A will be equivalent to the measure of the larger arc, which is BDC, minus the measure of the smaller arc, BC, divided by 2. So looking at our first example, in this case it's number 10, we're looking for the measure of angle KLM, which is this angle out here. So because these two secants intersect out here, outside of the circle, then we can use our formula. So we take our larger arc, which has a measure of 140 degrees, and we subtract the measure of the smaller intercepted arc, which is 66 degrees, and then we divide it by 2. So 140 minus 66 divided by 2. And when you do that, we get 37 degrees. So the measure of this angle, KLM, is 37 degrees. Find the measure of angle ABC. Again, that's this angle out here where a tangent and a secant have intersected outside. So again, that means that we can use our larger and smaller arcs. So here's our smaller arc that is intercepted by that angle. It has a measure of 62 degrees. The larger arc intercepted by the angle is this arc DA out here. The problem is I don't have the measure of that arc. So I need to find it. If I know that this arc AC is 62 degrees and arc CD is 88 degrees, then I can first calculate the measure of arc AD, this arc out here, because all the way around the circle is 360 degrees. So I can take away the 88 degrees and the 62 degrees to figure out what's left. And in this case, that would be 210 degrees. So this arc here is 210 degrees. That's what I'm going to use in order to find the measure of angle ABC. So the measure of angle ABC is equivalent to 210, the larger arc, minus the smaller arc, 62, divided by 2. So 210 minus 62, then divided by 2 is 74 degrees. So the measure of our angle ABC is 74 degrees. In number 12, we're looking for the measure of angle PQR, which we can see is this angle out here. I have my larger intercepted arc, which is arc PSR, and then the smaller arc is PR in here. And I can see that the larger arc is 313 degrees. So that means that the smaller arc, since we're looking at two tangents here, the smaller arc, which is arc PR, is what you would get if you take 360 and you subtract 313. So 360 minus 313 is 47 degrees. So this arc right here is 47 degrees. Therefore, if we want to find the measure of angle PQR, we can take the larger arc, which is 313 degrees, minus the 47-degree arc, and divide that by 2. And when we do that, we get 133 degrees. So that would be the angle. The measure of angle BCD, again, this angle out here, I can see that this arc measure, the larger intercepted arc, is 67 degrees. I need the smaller intercepted arc as well, which is not labeled. However, I can see that this arc, ED, is 94 degrees. Since AB is a diameter of the circle, I know that the arc from A to B should be 180 degrees. So if I take 180 and subtract 67 and 94, I'll be left with the measure of arc BD, which should be 19 degrees. So to find the measure of angle BCD, we're going to take the larger arc, 67, subtract the smaller arc, which is 19, and divide by 2, and we would get 24 degrees. Sometimes you're going to be asked to find the different arc measures, and you're given the angle measure instead. So in this case, I can see for the angle 40 degrees here, here is the smaller arc, 75 degrees, and then the larger arc out here is what we're looking for, which is the arc SW. So I'm going to call this X because that's an unknown for us. But the relationship is that our 40-degree angle should be equivalent to the larger angle, or I'm sorry, the larger arc measure minus the smaller divided by 2. So then it's a matter of solving your equation. So I can solve it like a proportion. Cross products are equal. So 40 times 2 is 80. That should equal the other cross product, 1 times x minus 75. So to solve for x, we would add 75 to both sides, and we would get that x equals, or this arc, SW, equals 155 degrees. The measure of arc QU is what we're looking for in number 15. So this arc measure here. We are given that your angle is 35 degrees. We also have that this arc here is 46 degrees. So we know that 35 would be equivalent to this arc measure, which we'll call x, minus 46 divided by 2. So again, solve using cross products. 35 times 2 is 70, and that would equal our other cross product, 1 times x minus 46. If I add 46 to both sides, we get that x equals 116 degrees.